Olá, boa noite a todos. Muito prazer, nós recebemos pesquisadores do Centro Internacional de Agricultura Tropical. Estão aqui conosco, Dr. Manejo, Dr. Horn, vem diretamente da Colômbia, estão nesse momento aqui na Universidade Federal de Santa Maria. Da mesma forma, nós cumprimentamos o Dr. Programa. Nesse momento ele está no Japão, de manhã lá no Japão, de noite aqui no Brasil, para nós iniciarmos o primeiro workshop de manejo sustentável de doenças em soja e em arroz. Quando nós falamos em sustentabilidade, nós precisamos gerar informações e cada vez mais fazer parcerias. A gente consegue construir ciência séria com parceiros de todas as partes do mundo. Então nós estamos muito felizes nesta noite aqui no Brasil, manhã no Japão, por ter esse seleto time de desenvolvedores de tecnologias para o manejo sustentável de doenças. Aqui representando então a Universidade Federal de Santa Maria, nós temos o professor Manejo Sustentável, que irá proferir algumas palavras.
Certo. Muito boa noite a todas e a todos, muito bom dia, muito boa tarde aos nossos seguidores das redes sociais Field Crops que nos assistem nesse momento ao vivo, ou então que estão vendo essa gravação depois desse nosso evento. Então, em nome da Universidade Federal de Santa Maria e da equipe Field Crops, nós saudamos a todos. Nós temos aqui muitos integrantes da equipe Field Crops, nós temos aqui colegas da Imater, RS Ascar, do Instituto Rio Grandense do Arroz, que também estão conosco aqui nesta noite. Então, muito obrigado a todos. Welcome to everyone who is watching this live from Brazil. We are very glad to have this first workshop. Good morning to our fellows in Japan. Very welcome. And to our fellow here in Brazil. Thank you very much. And I hope everybody has an excellent evening.
Muito obrigado, professor Manejo. Agora nós passamos a palavra para o CEO da CropSteam, o Dr. Michel, que é um dos responsáveis por hospedar então os nossos parceiros pesquisadores da Colômbia e do Japão.
Muito obrigado, professor Alencar, obrigado, professor Manejo. Nós, enquanto CropSteam, é um grande orgulho nós estarmos aí hospedando nossos colegas que vieram lá do CID e que estão aqui trocando experiências e principalmente inovação. Então, o nosso grande objetivo aqui, enquanto CropSteam, é representar então as startups dentro da Agência de Inovação e Tecnologia da Universidade Federal de Santa Maria, que hoje está voltada então para trazer um pouco do conhecimento gerado dentro da universidade, gerando ferramentas para estar auxiliando o produtor e as empresas rurais para aumentar a sustentabilidade e a produção de alimentos no mundo. Thank you very much, Dr. Manejo. Thank you very much for the opportunity and to share knowledge with us.
Muito obrigado, Michel. Muito obrigado, professor Manejo, pelas belas palavras e principalmente pela acolhida aos nossos colegas da Colômbia e do Japão. Então, nesse momento, nós iremos passar a palavra para o Dr. Programa, que vai fazer a apresentação para nós diretamente do Japão. Como a linguagem universal é o inglês, toda a palestra será proferida em inglês. Então, nós agradecemos a todos e vamos iniciar a palestra. Thank you very much, everyone, for appreciate this only opportunity to share knowledge about management, sustainable management about rice and soya. Dr. Corran, thank you for the opportunity, thank you for your time, and now you have the talk.
Yes, sure. So, Lenka introduced me already. Yes, sure. Hi, everyone. I'm Takashi Togami from SoftBank Japan, and I'm the leader of the agriculture IoT project supported by the Ministry of Internal Affairs and Communication Japan. Thank you very much for this opportunity. Thank you very much for giving me this opportunity to introduce our project. So I'd like to introduce our project and also introduce our solution, Ikakashi. So as you know, there are so many issues we have been facing in agriculture, such as productivity, sustainability, human resource development, environmental load, and climate change. In agriculture, there are many issues such as food safety and security, stable production, sustainability, water resources, worldwide population growth, and greenhouse gas emissions, and so on. On the other hand, it is extremely hard to cope with these issues or to solve these issues by implementing a conventional method which is based on experience and intuition. Therefore, new methods or tools contributing to solve these issues are strongly required. Now, I will introduce our IoT solution, Ikakashi. So we started agriculture IoT project named Ikakashi, and Kakashi means scarecrow in Japanese. So it is like electrical scarecrow keeps eye on your farm. And our vision is to drive the information revolution in agriculture while respecting our Mother Earth. When we make a plan or implement agriculture IoT project, we advocate this economic development model by the sustainable food production eco-cycle. As you know, there are so many issues in agriculture such as productivity, climate change, as I mentioned earlier, and many projects using new technology usually focus on productivity. But if it gains short-term success due to the lack of environmental care, leading to lower productivity for middle and long term, what do you think? So new technology can be introduced and used by researchers and staff assigned for the project, but within the project, if there is no activity to transfer the idea or theory of tool, solution, method, what do you think will happen after the project? That's why I thought up this model. Higher productivity with higher quality safety, sustainability in terms of environment conservation, and sustainability in terms of human farming with the idea or the theory, we should tackle these three circles at the same time. When carrying out each activity, science or data-driven is the most important component, because it is common trait satisfying the requirements of three circles. In other words, scientific approach to each circle is very effective and it is electrically formed. And the agriculture IoT platform consisting of IoT, big data, AI, and GPS is the technical backbone behind. And Ikakashi is designed to use the data for cultivation support. Therefore, we are not only focusing on data acquisition, but also more focused on data utilization for cultivation. So Ikakashi is a solution to help you implement science-based agriculture. Now, I'll move on to our concept. To contribute to solve the issues as I mentioned earlier, we have started to apply new technologies in agriculture. And that IoT, big data, AI, and GPS, which stands for Cyber Physical System, as you probably know. And IoT stands for Internet of Things. For example, sensing system, internet connection, and obtaining environmental data. Then gathering and storing enormous amount of complex data becomes big data. And the data is analyzed by AI, which is artificial intelligence, including such as machine learning and deep learning. And new knowledge obtained from the analysis is transmitted to the real world and used for automatic control in greenhouse, for example. Now I'd like to introduce our approach to data utilization. This is the screenshot of some contents of eCataxi visualizing data. And just like other sensor network systems, eCataxi can easily visualize the mutual data on the web. However, he is efficient. It's just visualization enough to support farmers, and our answer is no. This is because not many farmers know the relation between mutual data and agricultural crops for cultivation. So therefore, not many people know how to use data. On the other hand, there are a lot of knowledge found and accumulated by so many researchers. It is assumed that to utilize environmental data, we have to think from the plant science point of view. So please look at this slide, and this is an example of Japanese rice cultivar, Koshikari. And it is lined up by growing stages such as sowing stage, rooting stage, maturing stage, and harvesting stage. As you can see, in each stage, there is a number and cultivation know-how. In other words, these are value-added information. So to utilize better data, integration of scientific knowledge on plant technology, biology, physiology, pathology, and cultivation know-how with agricultural IoT is the key. So to utilize the collected data, the integration of scientific evidence and farming skill, knowledge, know-how is one of the key, as I mentioned. And we have been proposing the integration creation of science-based e-cultivation manuals. We name this India recipe. A recipe is like cooking, but in our case, it is a cultivation recipe based on scientific knowledge. This is just a conceptual drawing, but the integration of scientific knowledge with IoT technology will enable this navigation in agriculture. Now I'm going to introduce our application example and effects of implementation of scientific approach in Japan. We have some videos showing our successful case on YouTube. So if you are interested, please have a look later on. In our agricultural IoT projects, we are not only providing eCataxi, but also help analyzing collected environmental data based on plant science. In this example, the target crop is strawberry in a greenhouse. Within dot line in blue is the cultivation environment managed by the skilled farmers whose sales and quality is the highest in the area. Horizontal axis is a change in temperature in 30 minutes, and vertical axis is the average humidity resisting 30 minutes. So as you can see, the skilled farmers made the ideal environment, while other environments seem to be stressful for plants, and those stress have negative impact on photosynthesis. So to increase productivity, it is important to improve the cultivation environment. In our project, we also have a workshop just like today with the project members and farmers sharing analysis results. These workshops help farmers what to do and also help understand science-based agriculture. And this is the very successful result of data-driven agriculture. And this project was carried out in Nakata City, Fukuoka, Japan, and the target crop was high added value strawberry in a greenhouse cultivation. And since they implemented science-based agriculture and they improved the cultivation environment, as a result, they gained up to $8,000 per 0.1 hectare. And also, as skilled farmers increased their income, and also like younger generations they are also increasing their income as well. This slide summarizes the factors achieving the success based on our experience and hearing from farmers and local governments. There are three important factors that you can see. First one is the implementation of science-based agriculture or data-driven agriculture. It means data collection is not enough, but we have to utilize data continuously. To do so, analysis and workshop seminar by doctors specialized in agriculture informatics and agriculture information engineering. It may be overstated, but e-Kakashi is the only one which can provide such opportunity in agriculture Internet of Things industry. Secondly, the project size. Since we had 20 farmers, including young farmers and skilled farmers, which means we had 20 samples. Therefore, we could compare the growth environment between young and skilled farmers, and also it was effective to share information with farmers who do not deploy e-Kakashi. Lastly, the continuity. We could achieve more good results by utilizing our accumulated data, information, and knowledge through the project. So to achieve the success, we should keep implementing data-driven agriculture. For example, our rice project in Japan is since 2016, and in this Manhattan project is since 2017, and still continuing. And this is our latest success case in open field production, and that is the case of the potato. And by implementing science-based agriculture in open field production, we have good result that is increased up to 50% yield in potato production. So here, the right-hand side is the cultivation management based on experience and intuition. That is a conventional method. And left-hand side is here. That is based on the data. So, according to the scientific knowledge, they manage the watering optimally so that they can get very good results. Another activity I think is very important is human resource development. And I strongly believe that to implement art-blended agriculture with high yield sustainably, education for younger generation is extremely important. Therefore, we have made education projects for younger generation in cooperation with some of agricultural technical colleges. What we have been providing are the opportunity to learn about agricultural issues, advanced technology such as agriculture IoT, and science-based and art-friendly agriculture. In this project, students have opportunities not only to use IoT devices by themselves, but also to learn how to use data for cultivation supported by teachers and facilitators. Now I would like to talk about projects in Colombia and Ecuador. Our overseas project started with International Center for Tropical Agriculture, which abbreviation is SIAC. In SIAC project, what we are trying is to develop cultivation index and technology based on science for new cultivars that are able cultivation in dry area. And we started 2017, and what we did was not to collect environmental data first, but to create index samples. As a result, we confirmed that the created index can be used for predicting important growth stages. Therefore, it was expected that implementing appropriate cultivation practice will improve quality and increase in productivity. And we have been implementing a project supported by the Ministry of Internal Affairs Communication Japan. And this was a project Colombian government and Japanese government. And the final goal was improving productivity, human resource development, and environmental conservation. And we started the project in Ecuador last year. Even in the governmental project, we hold the workshop seminar like this. So after the workshop, project members and supporters of Colombia side could deploy and set up devices by themselves. And theoretically speaking, e-Kakashi can be applied to any kinds of crops. In fact, e-Kakashi is used for various kinds of crops. So we also applied e-Kakashi to tomatoes and vegetables in greenhouse cultivation in Colombia. And here we have some kind of screenshot of the workshop held in Colombia. And we have a workshop with project members and farmers sharing analysis results like we do in Japan. And these workshops help knowledge and technical transfer and capacity building. We have other projects in Colombia with IDB and SHIAT. Like this. So now I'd like to move on to the obtained results so far. But this is one of the results from our project, and this is a case of rice production. By accumulating scientific evidences, it is possible to provide beneficial information as an alert system to farmers. And this graph shows relationship between yields and accumulated daily temperature after heading to harvesting. We revealed that there is possibility to increase productivity by detecting optimal harvesting timing. And please look at the graph on the right. As you can see from the graph, the highest is at the accumulated temperature of 800 to 900 degrees Celsius, and after that, it decreases. Generally, this is caused by the decrease of water content in unhulled rice due to overdry and by bird damage. However, setting 900 degrees Celsius as the threshold value, we can provide farmers with information and alert to prevent delayed harvest. And also, the accumulation temperature has less error in the area, so positive effect is expected by using one e-Kakashi in an area as a representative value and providing alert for preventing delayed harvest. On the other hand, data collected in farmer field also deviates from the curve due to various farming practices. Based on these, to improve and achieve a higher accurate distance approach system, it is very important and necessary to collect not only environmental data but also information on farming practice globally. Next result is water depth monitoring. Please look at these graphs. Horizontal axis is the time and vertical axis is the water depth. Line graph is the data collected by our sensor system, and bar graph in blue is the recommended value of water depth. No paddy field could satisfy the recommendation as you can see. Okay. One of the results is the paddy doesn't have structure to store the recommended value of water. So if farmers try to irrigate water by following a guideline without moving the paddy doesn't have such structure, it means they are wasting water. And these water depth monitoring will help construct optimal water management methods. And in addition, these water depth monitoring system will help reducing the methane from a paddy field as well. And this is the case in Ecuador. And last example of our observed a disease alerting system. In many countries, there are many scientific knowledge accumulated on famous and common pests and diseases such as rice blast. So according to the analysis results from previous pest damage records and the climate information, the farm that was 30 kilometers away at most from weather station on had a pest damage. Therefore, we verified the prediction algorithm if it was applicable in the range. And start in orange is the day when rice blast was observed at actual fields. And T in red is when the system gave rice blast alerts. In our verification experiments, rice blasts tend to be observed at the field after 5 to 10 days after the alert. If the prediction can be provided to farmers, agronomists, or growing advisors at the right time, they can use pesticide before getting great damage and could take action to prevent disease. Through these activities, we will continue to achieve the increase in productivity and improve quality in the whole target area. Since we have the experience, we started the project in Brazil last year. And in this project, we would like to support solving these issues in greening based on Japanese advanced technology and best practice in Japan. The key is agriculture information platform, and the platform consists of 3 components, which are sensor devices that collect environmental data, IoT technology that stores data in the cloud stably, and artificial intelligence that navigates calculation from big data like car navigation. In order to support solving the issues of improving productivity, human resource development, and environmental conservation in the agriculture field, we will conduct demonstrative research on agriculture IoT platform utilizing Ikakashi. In Japanese fiscal year 2021, we implement 3 components. One is activation of Ikakashi system in Brazil and the construction of agriculture platform on trial. Second one is testing sensor system, and the last one is the implementation workshop as a part of human resource development, just like today. And in this year, we have 2 phases. Phase 1, we actually do the telecommunication test. If we can connect to the telecommunication system in Brazil, and after that, we are actually deploy Ikakashi in real field and trying to get the environmental data. And our target for this year is soybean. And usually, once the project started, it continues 2 or more years, but because this is only a single fiscal year project supported by the Ministry of the Internal Affairs and Communication in Japan, and next year is not decided. But Ministry of Internal Affairs and Communication people, they seem to continue next year as well. So what we do again is here, we actually install Ikakashi in the field and try to get the data. And in the future, what's important is to share these value-added information or environmental data to whole food industries. So Ikakashi have already prepared API. So we would like to collaborate with other system or solution so that we can actually give the beneficial information and solution to users. And The third thing we are doing in the workshop, as I mentioned, a lot. And this is one of the idea of the project structure. And we have the sponsor that is the Ministry of Agriculture, Ministry of Internal Affairs and Communication Japan, and project supporter here is Mofa Adna. In Brazil, project team, UFSM, Federal University of Santa Maria. Thank you for the greatest cooperation, and also Japanese company Kaneka. And here, Eastern Sunday is a great help. Thank you very much again. And this is just an idea of the project schedule. We have, as I mentioned, this is the Japanese fiscal year project. So this year's project is the March 2022. And I try to continue this project next fiscal year as well. Thank you very much. And I'd like to keep our activities and contribute to make better world. And this is end of my presentation. Thank you for your kind attention. Thank you.
Thank you, Dr. Kogami, for the great presentation and for trusting us to do this work with you, with the guys from here. For us, it's a good opportunity. And now we have time for some questions and comments. So here we have some students, some extension guys, and now we have some time to do questions for Dr. Kogami. I invite Mauricio, please, to do the translate. Professor Manejo have the first question.
Well, it seems that all the effort to improve agriculture production worldwide is a global challenge. So first of all, I congratulate all of you guys to have worked on this effort. And could you please clarify again how is the project going in Brazil now? It's starting now.
Do you hear Professor Manejo, Dr. Kogami?
Sorry, I couldn't hear his question clearly.
Okay, Professor, could you come here, please? A moment. Professor, you.
Yeah, first of all, congratulations for the presentation. I was just wondering if you could clarify a little bit more how is the project going here in Brazil? Is it starting now?
Well, our project started last year, December. And this is the only first step of the project. So what's important is to verify if e-Kakashi can be activated in Brazil or not. And this is the only purpose for this year. And hopefully Japanese government decide to continue next year. And next year we will try to acquire or collect environmental data a lot and analyze so that we can actually detect the some kind of improvement. Thank you.
Thank you, Professor Manejo. Now Michelle is coming here to do another question, Dr. Kogami. After that,
Sure.
Lorenzo, Camille, we have a lot of questions.
Hello, Dr. Kogami. Thank you very much for the great presentation. Very good. Dr. Kogami, I sugar farmers. Is that possible to identify through a Kakashi? And if yes, how is it possible?
Okay. Well, it is possible to detect who is not skilled and who is skilled. Okay. So, as you probably know, plants do the one thing, that is photosynthesis. Okay? And very skilled farmers, they are actually creating very good environment for photosynthesis. For example, change in temperature in 30 minutes, probably about 5 degrees Celsius change in 30 minutes, that is very stress for plant. So what skilled farmer does is actually open the window bit by bit, time by time. So they are actually trained not to change in temperature dramatically. And they know the method by their experience and intuition. But because young generation unskilled farmer doesn't have any idea, and they have kind of the idea that the higher temperature is very bad. So what they do is actually open the window straight away when they know the temperature higher. But that gives a plant another stress, and we can actually detect through the environment of date change. How simple is that?
Very good, very good. Thank you very much, Dr. Kagami. And I have another question. Tomorrow we'll go with a very, very good farmer, and we'll install there the Kakashi, and probably we'll stay there for some period, and some time after we'll take off the Kakashi. Probably he will like this Kakashi system. And he will ask us if it is possible to buy and how much it will cost. So this is the question.
Okay. Well, now we are not ready to sell Kakashi in Brazil because we don't have certification yet, and we don't have any distributor. Okay? So we are trying to get that this kind of certification through our project period. So probably in 2 years, hopefully we can get the certification. But in Japan, we are selling one Kakashi device, as you probably see the new device. That is $1,000 US. And sensors that is depending on variation. For example, temperature and humidity sensor, that is about $60 US. So it depends on sensors. So previously, we sold Kakashi system about $10,000 US, and that was too much, right?
Right.
And so we knew Kakashi so that so many people can use Kakashi.
Thank you very much, Dr. Kagami. Thank you very much.
Thank you. We have another question here from Moreno.
Good morning from Rio, Japan, Dr. Kagami. Here in Brazil.
Good evening.
Live. Congratulations on the presentation, really good presentation. We learned a lot
Thank you.
from you, and we are having also good time here with Dr. Manejo Sustentável. Thank you for the opportunity of it. And watching your presentation, I think about a point. You talked a lot about the occupation and the issues with young people and young farmers in Japan, Soja, and Ecuador. And here in Brazil, how do we and how can we use your experience with the Kakashi to help our people?
Well, what I'd like to do in the project of hopefully continue next year, I would like to compare the data between skilled farmers and younger farmers or unskilled farmers, so that we can actually review the difference between skilled and unskilled farmers. So once we detect the difference, then we can ask skilled farmers what to do to create this environment. That is the actually cultivation management method. That is a very good experience and intuition based. So we are trying to get the difference through the environmental data analysis, then try to get what to do or what skilled farmers do for creating better cultivation environment. So once we detect that cultivation method, then we can actually transfer the knowledge to skilled or unskilled farmers, so that they can actually learn quicker than ever before. So once they have this idea and cultivation method, of course they have more opportunities to create better cultivation environment for the cultivation or farming, so that it will lead to the higher productivity.
Very good, very good. Regarding the research environment now, and we agree, totally agree with you, and we really believe that it will make a huge difference for the future generations. Thank you.
Thank you very much.
Now, Camille.
Hello, good morning. So
Good
I have a question
morning.
about the distance of the Ekakashi can take the environment. I mean, if a farmer get the access to Ekakashi in this farm, but like his neighbor has one Ekakashi in his farm. You use the same. You have like a distance that one Ekakashi can
Cover the area, right?
enjoy the environment, or you will put another one.
Well, it depends on how to use the data, or what kind of issues you would like to solve. Okay? As you know, the soil environment is different spot by spot. So if you try to understand the soil environment very properly, you need a lot of interaction. But I believe that is nonsense, because it costs a lot. So our idea in open field to utilize this environmental data, we use representative value. For example, please look at my background here. That is a picture of Colombia. So global Brazil will be pretty much the same. So very flat and open field. And this open field, solar radiation and temperature humidities, they are not different in the area. So we can use these data as the representative value of area, and we use these environmental data for predicting harvesting timing or disease detection, covering about 20 square kilometers or sometimes more. So we can actually share this environmental data in the area of the farmers, so farmers are more beneficial with low cost. That is our idea.
Thank you. Congratulations for the presentation.
Thank you very much.
Thank you, Dr. Togan. Now we have a question from a woman. This woman is a CEO, startup here in our university. The name of the startup is Safe. It is maybe the best one startup we have here. So Mauricio will do the question.
Hello, Dr. Togan. Good morning.
Hello. It's a very good question. Well, right now we can select 6 types of sensors, and we have to actually customize the e-Kakashi to connect new sensors, because the connection port or connection part that is very unique, the parts we are using. So we have to actually adjust to the parts, and also once we connect the new sensors, we have to detect the numbers and we have to process the data. So we have to do the big update of the software as well. But many people think, and I believe, what important is the data collection, not the sensors and not the gateway. So what we are doing is actually trying to increase the variability of sensors. So probably next year or the year after, we will increase the variation of sensor which can be connected to e-Kakashi.
Thank you very much. I have my own action.
Yeah, sure. Go ahead.
I'm concerned about soil and water irrigation systems. And how could I use e-Kakashi data to irrigation management? I mean, in the large area. Just data is enough, or could I have something related to water balance in the soil?
Okay, so we can connect the soil moisture sensors. So we can actually detect.
No questions? Okay. So, Dr. Webb, thank you for your time, for a great presentation, and we would like to invite you to visit us here in Sustentável. It's a pleasure to receive you. And now we will invite everyone here go to the center and take a picture. Bom, então, com relação à transmissão, nós gostaríamos de agradecer a todos pela presença. Caso vocês tiverem dúvidas sobre o e-Kakashi, por favor, nos contatem pelas redes sociais. Uma boa